If you'll think back, we did an independent groups t-test, and then we did a correlated t-test. Then we did analysis of variance. Well, the next logical step would be to look at analysis of variance where we have a repeated measures, just like we had a dependent t-test. We're now going to look at a one-way within groups ANOVA, also known as a repeated measures ANOVA. For a quick review,
remember, with the independent t-test, and in the two groups you have separate subjects. No subject appears in both conditions. For the one-way ANOVA, you can have 3 or more groups, and in each group you have separate subjects again.
With the dependent t-test, you have the same people occurring on both occasions, in this case time 1 and time 2. We did a paired or correlated t-test. That's to say the same people occurred in each cell. The next logical extension of that to analysis of variance is represented here, a within groups or repeated measures design. The same people appear across each one of the times or occasions.
The subscripts here next to S indicate first what time is involved, and the second subscript is what individual is involved. But in this case, all individuals are the same in each one of the times.
So let's further investigate the repeated measures or within groups analysis of variance. Notice first that the observations are not independent. Think about that now. The same people appear in each one of the cells. Well, they can't be independent. And independence of observation was one of the assumptions from analysis of variance. How do we handle that?
We have a new assumption called the sphericity assumption.
The sphericity assumption is based upon the correlation between the levels of the repeated measures and the variances within the repeated measures. It's analogous to the homogeneity of variance assumption with the independent t-test or analysis of variance, wherein now the assumption has to do with the correlations and the variances across the levels of the independent variable. So the sphericity assumption is tested with SPSS. When it's tested, you get 3 different estimates of what's called epsilon. Epsilon is what's used to adjust the degrees of freedom. Essentially, the tests are exactly the same, but if the sphericity assumption is met, epsilon equals 1. So there's no adjustment in the degrees of freedom. However, if you violate the sphericity assumption, then the degrees of freedom are reduced. Recall that as degrees of freedom are reduced, you have less power. You have less power, you have a higher critical value necessary to reject a null hypothesis. The 3 corrections that are presented on SPSS are the Geiser-Greenhouse method, the Huhn-Felt method, and the lower bound method. The lower bound method is the most conservative method of adjusting the degrees of freedom. And importantly, the only thing that changes is an adjustment in the degrees of freedom. When you adjust the degrees of freedom, that'll have an impact on the probability.
The F ratio that you obtain remains the same, only degrees of freedom change.
And you compare that F ratio to the critical F ratio needed for the associated degrees of freedom. We'll illustrate that with an SPSS example in the next video.